So let's get started and let's begin with a short introduction to mechanics. So how do we deal with mechanics in this class, or how do we want to think about mechanics? So first of all, mechanics is a sub-branch of physics. And in other words, we need to understand what physics is, right? And physics is really the description of nature, right? So physis is Greek for the description of nature. And so really physics tries to explain nature and the universe, if you will. So we use mathematics to explain the universe. So use mathematics to explain nature and the universe. So we know that physics expresses the world around us, and we know that mechanics is a sub-branch. So what sub-branch is mechanics really? So mechanics really deals with specific types of physics. And that is, we deal with physics that is concerned with the behavior of bodies or objects under the influence of forces or displacement. So we're really dealing with forces and displacement. Forces, anything that's pushing or pulling on a physical body, and displacement, anything that makes it move in any direction. And this can technically happen at any scale, right? So this can happen at any scale. So for example, you can have atoms which are as small as 5 times 10 to the minus 11 meter in radius. So this is the radius. Or you can deal with objects as large as, for example, as the Earth. And that has a radius of approximately 6.378 times 10 to the power of 6 meters. And so you see that mechanics really can deal with like any size. And here we have differences of 17 magnitudes. But in this class, of course, we deal mostly with structures. And one of the most famous one, at least here in the United States, that I like to use, has a total height of 93 meters. And I let you figure out which iconic American structure this is. There's another famous iconic structure that every engineer should know. This is in Europe, and that one has a height of 3 times 10 to the 2, or 300 in total, meters. And I let you also Google which one that is. You should be familiar with those two numbers. As an engineer, you want to know when it comes to structures which two structures I'm talking about here. So I wish you good luck finding that information. Now, if you deal with very specific sizes in certain branches of mechanics, or physics, I should say, then you deal with very specific subjects. And so, for example, if you deal with super tiny elements, so for example, on the atom level, then you talk about quantum mechanics, right? Then you would deal with quantum mechanics. If, on the other hand, you deal with super large elements, so for example planets and so on, then you would use general relativity. And of course, those are topics we don't deal with here in this class. In fact, we deal with something that is called the macro scale or the macroscopic scale. And therefore, we deal with classical mechanics, is what it's called. And that is what we deal with here in this class. And I consider macroscopic scale anything that I can touch and still see like within close range, I want to say. So this is something that is our everyday scale. Any building that you are aware of, any structure, any car, those would fall into macroscopic scale. So we may want to remember that this includes things like cars, structures, projectiles, and so on. So this is what we deal with here in this class. And you could now take the classical mechanics and further subdivide it. There are things like Hamilton, Lagrangian mechanics or continuum mechanics, fluid mechanics. We don't want to worry about this right now. If you really want to take a fun class that really breaks your brain, I would say start with something like continuum mechanics. And that is something that engineers deal with on a graduate level. And you then would need to be very familiar with that. And the only way you can understand things like, for example, let's say continuum mechanics. I'm going to make a side note here. Continuum mechanics. And the only way you understand continuum mechanics in your later career is if you have a solid understanding of classical mechanics. And that is true for other disciplines as well, Lagrangian, Hamilton mechanics, things that you don't even know yet will be ahead of you, but you will need classical mechanics to have access to that knowledge. So we are really starting from the ground up here and kind of like the grandfather method of mechanics, which is the Newtonian mechanics. Newtonian mechanics. And that is the heart of this class, and everything we will deal with in this class is based on those principles laid out by Newton. And so we will talk about that. And to talk about that, we need to understand more about rigid bodies. And so let's now move into rigid bodies and what they are to us.